Okay guys, welcome back. Today we're going to be continuing with our unit circle, building it and talking about sines, cosines, and the beautiful sort of symmetry that is in those functions. So today we're going to be talking about the fundamental identities. And we've touched on this before, but I just want to make it really explicit. And in case you didn't get it before, this is going to hopefully cement it into your minds. Now the fundamental identities, this is of course relating to trigonometric functions. So our objective today is basically just to recognize and use them. And by recognize, really, I mean I want you guys to sort of know, be able to recall them, recognize and use fundamental identities. Okay. Now there's 6 fundamental identities, or 6 trigonometric identities, okay? And they, of course, start off with sine and cosine. I'll just jump right in here and give them to you guys. Hopefully you know them already. Then I'll give you some examples and some problems that we can use to be able to solve them, okay? So say I've got the sine. It all starts with the sine of an angle. So I'm going to say sine of theta. Now the sine of theta is, of course, our y value on our unit circle. And our cosine of theta is our x value. It all starts from there. Now the relationship between these two, of course, is the tangent of theta. Or the relationship when you combine these two is the tangent of theta, which is going to be the sine of theta over the cosine of theta, which is equal to, of course, we've got y, sine of theta is equal to y, and the cosine of theta is equal to x. So this is already, I've got 1, I've got 2, I've got 3 of my fundamental identities. Now the last 3 that I've got, 4, 5, and 6, they're just the same ones, but they're the reciprocals. Okay, so then I can say the sine of t, if I take the reciprocal of this, I'm just going to give this a function a name. I'm not going to give it a name. Somebody gave this function a name. And it's the cosecant. Sorry, not t. I'm going to stick with thetas. And it's going to be the cosecant of theta. And so likewise, if I take the reciprocal of both of these, I can just say, I can define the cosecant of theta, and that's just going to be equal to 1 over the sine of theta. I can do the same with the cosine and the tangent. So the cosine of theta is going to be equal to 1 over the secant of theta. Or, taking the reciprocal of both sides, I can, and flipping them like this, I can say that the secant of theta is defined as 1 over the cosine of theta. And the last one, so this is going to be my 4. This is going to be my 5th identity. And my last one that I've got is, of course, my tangent of theta, 1 over the cotangent. Or, if I want to look for my 6th and final identity, I can basically, I can say the cotangent of theta is equal to 1 over the tangent. Now the great thing about these identities is they're so interrelated. Once you know one of them, you can figure out or remember, derive what the other ones are going to be. So if you know sine, you know cosine, you remember that tangent is sine over cosine, you can derive everything else from there. All you need is the sine and the cosine. And that's what I'm going to give you guys right here. In this example, right, I'm going to say the sine of theta is equal to 2 over 5, and the cosine of theta is equal to the square root of 21 over 5. And I want you to figure out what the values, or we're going to figure out what the values of the 4 remaining identities are. Okay, so I know that tangent, that's going to be my next easiest one, tangent of theta is equal to the sine over the cosine. Okay, so the sine is going to be 2/5, and the cosine is going to be square root of 21 divided by 5. Now this is a tricky sort of manipulation that I think catches a lot of people up, but remember, don't be afraid of these fractions over here. So if I have these fractions, another way to write this, if you're having trouble with this, is 2/5 divided by, use the old school division sign, square root of 21 divided, or over 5, right? So 2/5 divided by 21 over 5, 2/5 divided by 21 over 5. Now this division sign, because I've got two fractions, I can flip this second fraction and turn it into a multiplication. So I can say this is going to be equal to 2/5 times, instead of 20 next square root of 21 over 5, I can say 5 over square root of 21. Now the 5's cancel, and I just end up with 2 over the square root of 21. And I would be totally 100% happy there, except I've got this radical in the denominator, and I don't like that. So how I get rid of that is I say 2 over square root of 21, and then I multiply the top and the bottom by the square root of 21. And this doesn't really anger the algebra gods, because the square root of 21 over the square root of 21 is exactly equal to 1, right? So I'm just multiplying something by 1, totally legal, totally fine. And so after I do that, I get 2 square root of 21 divided by, and square root of 21 times square root of 21 is just 21. So then this is going to be equal to my tangent of theta. And I'm going to say this is tan theta. Awesome. So I've got my sine, my cosine, I calculated my tangent. Now let's figure out what our other three are. Okay? So I know that the cosecant of theta is equal to 1 over the sine of theta, or the reciprocal of sine, which now my sine is 2/5. So that means that my cosecant is going to be 5/2. Done. Got that one figured out. Now my cosine, oops, sorry, not my cosine. I need to find my secant. My secant, my cotangent. So my secant of theta is equal to 1 over the cosine of theta, or the reciprocal of cosine. Easy enough. Let me show some stuff around here. 1 over the cosine of theta, and my cosine is square root of 21 over 5. So taking the reciprocal is going to be 5 over square root of 21. Once again, I'd be totally fine with this, except now I've got this square root of 21, this radical is in the denominator. I don't like that at all, so I'm going to multiply the top and the bottom by root 21. Kind of do the same thing, and I just end up with 5 root 21 over 21. Awesome, that's going to be my secant. Now my cotangent, theta, is 1 over the tan of theta. Now I could do the same thing, I could just pull my tan right here, but if I remember back a step before I even simplified this, right here I've got 2 over 21. Now the reciprocal of that is just 21 over 2, or sorry, root 21 over 2. And that's going to be my cotangent. Now all I did here was, and even if you go here and you multiply the top, you take the reciprocal and you multiply the top and the bottom by square root of 21, you'd be totally fine with that. And you'd eventually end up with this, you just have to do a little bit of reduction. However, I just pulled it from here because I remembered back here I had 2 over square root of 21. And if I take the reciprocal, then I don't have to worry about that radical in the denominator, which is exactly what I've got here. Awesome, class. Hope you guys are getting this stuff down. Don't forget these 6 identities right here. Get these memorized. I don't want you guys to memorize a whole ton in this class, but this is something that's super important. It's going to help you figure out what the rest of the unit circle is. Okay, here's the example. We're going to pick up more examples like this in class tomorrow and just drill this home. I want you guys to be super, super comfortable doing this stuff. All right? I'll talk to you guys tomorrow. Look forward to seeing you.